Okay, so our previous video was about verifying that something was a solution to a differential equation. So if you're given a differential equation and they give you a potential solution, you can find out whether or not it's a solution, but at the moment we don't really have any tools for actually solving them. And this whole video is about that. In some sense, there's what I consider to be a pretty straightforward four-step process for solving differential equations, rather for solving separable differential equations. Solving differential equations in general is actually a really, really complicated field, an awesome field of mathematics. For this class, all you have to deal with is separable differential equations. And what it means to be separable is basically that you're going to be able to get all of the x terms on one side of the equation and all of the y terms on the other side of the equation. And once you've got, all of your x terms on one side and all of your y terms on the other side, we can basically integrate both sides and find out what the solution is. This will be a lot more clear as we get into an example. So let me go through those four steps. So, and you can pause, you can write this down. I don't know that I need to read these out loud. I'm going to go through all of them in the example that we get to right here. But the short of it is, you'll write y prime as dy dx. You'll multiply both sides by dx. Then you'll separate the variables, which just means get all the y terms, get all the dy's to one side, get all the x's and the dx's to the other side, and then you'll take the antiderivative of both sides, and you pretty much win. So if you've got those steps written down in your notes, keep going. I'm going to do one example with you, and then I'll give you one that you can sort of try on your own. So the first example, the one I'm going to do for you, is this one. I want us to find the general solution to this differential equation. So on the previous slide, I said that the first step was supposed to be that we take any y primes that we see and we write dy dx instead. So now I have dy dx over 2x minus 5 equals y squared. That was basically step one right there. Right? And at the moment it looks like things are worse. But, oh well, we'll deal with it. Step two was that I'm supposed to take this thing and multiply dx to both sides. Now, why does that make sense? The reason it makes sense is that dy dx, by definition, has a dy on the top and a dx on the bottom. Which means that if I multiply dx to both sides of this equation, now over here it's basically dx over 1, what happens when that dx multiplies with the top of this fraction? You should notice that that dx is basically going to cancel with the dx that's here, right? So when that's done, I end up with dy on this side, dy over 2x minus 5, and on the other side I have y squared times dx. This thing here was effectively step 2 that just happened, right? Now, step 3 is the step where all of the actual work resides, and I need to make something very clear here. When we multiplied the dx to both sides, I basically declared this side as the x side and this side as the y side. So anything that's on the wrong side, we need to move. So for instance, this is the dx side, this y squared needs to move over to this side somehow. And this 2x minus 5, I mean, technically the x is in the wrong spot. It seems pretty clearly to be connected to the other stuff, so all of that needs to move over to this side somehow, right? So how am I going to accomplish that? Well, I could certainly divide both sides, and I'm going to do this all in one step. I could divide both sides by y squared, and I could multiply both sides by 2x minus 5. So if I were to do that, I would end up with y squared dy equals 2x minus 5 dx. And like I said, I mean, like that right there was step 3, and I did it all in one step. So if you need to pause, rewind, look at that again and make sure you're clear on that. If you need to take 2 steps, take 2 steps, but make sure it's clear to you how that happened. So now, please note clearly that these two sides have now been separated. The variables have been separated. This is an entirely x and constant side. This is an entirely y and constant side. Once you've gotten to that step, you can do step 4. And step 4 is basically where we take the antiderivative of both sides. Now, I might point out that can only be done after you've separated variables. If there's still a y in this side, integrating is impossible. If there's still an x over here, this integral can't be done. So please watch out for that, right? So when I integrate here, the left side ends up being 1/3 y cubed equals, the integral of the other side ends up being x squared minus 5x. Now, you may be wondering about the plus c. In my steps in the previous page, I said that you're supposed to put the plus c only on one side. And the reason for that really is, if you put a plus c on this side and a plus c on this side, they're different c's. So as soon as you put one of them here, I would just subtract it over here, and you just end up with a different plus c. So, plus c. And truth be told, like that's it. This is the general solution to the differential equation. Now, some people might want to solve for y. It depends on what the question said. If it was multiple choice, you need to make it look like what they had. So, if we wanted to solve this for y, I'd multiply the 3 over. That would give me 3x squared minus 15x. Now this is plus, c2, some other constant. And then again, solving for y, I guess we could cube root both sides. The steps that I'm doing here are somewhat unnecessary. I'm fine with either one of these two answers. They're both good solutions as far as I'm concerned. So that's the example, the end of the example I have here. One last comment I would make. This is what's called a general solution, and we've talked about that before. The general solution is the one that includes c. So if you have a general solution, it means you haven't solved for c. Now, how do you solve for c? If this problem had given us a point, if they had said, passing through the point 1, 4, then you'd plug in 1, you'd plug in 4 for y, you'd plug in 1 for x, and you'd be able to solve for c. In this case, I didn't do that one. We will do that in the next problem. So the last problem that I have, the last example, is I now do want us to find that particular solution. And remember, particular solution basically means, we're going to need to find c at the end, right? So we want to find the particular solution to the differential equation given below, passing through 2, 9. I really would highly recommend that you try this problem on your own. And you might want to do it in steps, like do step 1 and then unpause my video and watch it. Then do step 2 and unpause it. And do step 3 and unpause it. Like, step through it and make sure that you've got this. So here we go. Step 1, we rewrite dy dx instead of y prime. Right? So this was step 1. So now again, if you're doing this legitimately, pause the video, do step 2 on your own. Step 2 is really easy. All you have to do is multiply the dx over. That was step 2. Now again, if you're doing this on your own, pause it, do step 3. Step 3 is supposed to be where we separate, right? So this is the dx side, this is the dy side. So the only thing misplaced is the square root of y. So I'm going to effectively divide the square root of y to both sides. This ends up giving me dy over root y equals x dx. This was step 3. Because now this is the y side, it's all y. This is the x side, it's all x. Now that I've done that, we will go on and do step 4. Again, if you're doing this at home, pause the video, try it on your own. Step 4 is the one where we take the antiderivative of both sides. Okay. Now the right side is really easy. We can tell that's 1/2 x squared plus c. On the left side, you may want to rewrite that. You may want to write that as y to the negative 1/2 dy. Note that on the right side, I don't write the integral symbol anymore because we took the integral. On the left side, I am still writing the integral symbol because I haven't yet taken that integral. I really, really want you guys to practice using that notation and being careful with it. So when we do an antiderivative, we increase the power by 1. That becomes y to the 1/2 times the reciprocal of that, so times 2 equals, and we have our 1/2 x squared plus c. Right? So yay, this is my general solution. My general solution is 2 root y equals 1/2 1/2 x squared plus c. This thing here is my general solution. That's where we stopped on the previous problem. To find the particular solution, we need to go one step further than this. We need to solve for c. Solve for c using the point 2, 9. So I have 2 root 9 equals 1/2 2 squared plus c. 6 equals 2 plus c. That means c is 4. And so my particular solution is the same function I had up above, 2 root y equals 1/2 x squared. The difference is now it's plus 4. That's the particular solution. Now, just like I said in the previous video, if you wanted to, you could rewrite this. We could multiply both sides by 2 and get x squared plus 8 and then square both sides. This answer is also acceptable. I'm fine with either one of them. That's all I have in this video. We just have one left, and I'm hoping I can keep it on the short side, so wish us all luck.